In this video, we're going to be solving a very interesting equation. We have 2xy minus x to the fourth minus y to the fourth equals 1/2, and we're going to be solving for x and y values. In a little bit, I'm going to tell you why this equation is very interesting, and hopefully you'll agree with me on that one, and let me know what you think. So, to be able to solve this problem, we can try to put everything on the same side like this: x to the fourth plus y to the fourth, and then minus 2xy plus 1/2 equals 0. And then we can try to kind of complete the square here. That's probably going to be pretty difficult. But there's actually another idea that is super duper helpful. And the reason why this problem is so interesting, are you ready? Is because to solve it, we're going to use inequalities. Okay, that's why this problem is interesting. And what is really interesting about this problem is that there are two variables, but only one equation. And we're not necessarily looking for integer solutions. So in other words, this is not a Diophantine equation. It's not a number theory problem. This is an algebra problem, purely algebraic. That's what I like. Anyways, I hope you agree with me on that one. Let's go ahead and see how we can solve it by algebraic means. So first of all, I want you to consider the following. If you have x squared minus y squared squared, would you agree that this is going to be greater than or equal to 0 if x and y are real, right? So this gives us the following: x to the fourth power minus 2x squared y squared plus y to the fourth power is greater than or equal to 0. But that's not what I'm trying to get. I want to isolate x squared y squared. Let's go ahead and add that to both sides. X to the fourth plus y to the fourth is greater than or equal to 2x squared y squared. This is also called the Cauchy-Schwarz inequality, I think, or some people call it Cauchy-Bunyakovsky, depending on, you look at like who is naming it. Same idea goes with the cubic formula, whoever found it first, right? So anyways, this is just an inequality that is well known. And now we're going to apply it to our situation. Notice that we have fraction on the right-hand side. You don't like that. Why don't we go ahead and multiply everything by 2? That gives us, and let's save this inequality for future use, okay? You see, I told you this problem is pretty interesting. Now I'm going to go ahead and multiply everything by 2, 2x to the fourth minus 2y to the fourth equals 1. And then let's go ahead and maybe put everything on the same side, but isolate the xy. So in other words, add 2x to the fourth, 2y to the fourth to 1, and then 4xy will be on the right-hand side. Make sense? Cool. We're also going to hold on to this because I need to use this inequality. But notice that in my expression, I have 2x to the fourth and 2y to the fourth. But I only have one of these. So why don't we just multiply everything by 2, which is fine, right? 2 is a positive number. We'll get 2x to the fourth plus 2y to the fourth is greater than or equal to 4x squared y squared for obvious reasons. And now we can do the following. We can isolate this one from this equation and plug it in here. Oops, that's not what I meant, but anyways, that just became a box. And then we're going to go ahead and plug it in here. Let's isolate it first. What is that equal to? It is equal to 4xy minus 1, because you need to subtract it, right? Cool. Now we got another inequality, which is nice, because now this is kind of quadratic. Nice. So now let's go ahead and factor it out. I mean, not quadratic, it's kind of quartic, but it's easier to handle. You'll see why in a little bit. Let's put everything on the right-hand side. 4x squared y squared minus 4xy plus 1 is less than or equal to 0. Now, this is awesome. You know why? Because inequalities can be used to solve equations. That's what's awesome about this problem. I can't emphasize that enough. Now, what is the left-hand side? Have you noticed? It is a perfect square, and that's just perfect. So we can write this as 2xy minus 1 quantity squared, and that should be less than or equal to 0. Wait a minute. No square can be negative. What does that mean? It means that 2xy minus 1 cannot be less than 0. It has to be 0. That's a must if x and y are real, and I already told you we're looking for real solutions. Didn't I? I hope I did. From here, we get the following. xy equals 1/2. How awesome is that? Now, how do we use that information? In a couple different ways. You can isolate y and write it as 1 over 2x, and then consider the equation that we had and just plug it into that one. What was the equation that we had? Not the inequality, the equation. It's this one. Yay. Let's go ahead and use it. 2x to the fourth plus 2y to the fourth plus 1 equals 4xy. Now I'm going to replace y with 1 over 2x. 2x to the fourth plus 2 times y over y to the fourth, which is 1 over 2x to the fourth power. That's going to replace y. Plus 1 equals 4x times y. By the way, if you already know that xy is equal to, what is xy? Well, if you know that xy is equal to 1/2, that should be easy, right? So we're going to go ahead and just replace xy with 1/2. So it's just going to be 1/2 here. Oops. 4 times 1/2. That's going to be a 2. Nice. Now notice that when you expand this, it's going to be 2x to the fourth plus 2 times 1 over 16 x to the fourth power plus 1 equals 2. And now 2 goes into 16 8 times. And if you use substitution here, which would make a lot of sense, why don't we replace x to the fourth with something like z maybe? Not complex, but just z. 2z, or not 2z, plus 1 over 8z is equal to 1, because we subtracted, right? 1 from both sides. Notability or the pen sometimes it goes crazy. Don't worry about that. Now, we're going to go ahead and cross multiply. That's going to give us 16z squared plus 1 equals 8z. And then 16z squared minus 8z plus 1 equals 0. Uh-oh, another perfect square, which is perfect. So from here, we get z equals 1/4. But z is x to the fourth power. Awesome. If z is x to the fourth power, from here, x will be the fourth root of 1/4, which is the square root of the square root of 1/4, which is the square root of 1/2, or just 1 over root 2. And of course, they should be equal. X and y are equal. Think about y, because their product is 1/2, obviously, from symmetry. And then x can also be negative 1 over root 2, and that's also equal to y. So basically, there are two solution pairs. Let's write it down. 1 over root 2 over, 1 over root 2, and the other one is negative 1 over root 2. And I didn't rationalize the denominator, so I apologize. Forgive me for that, because sometimes when I do, people don't like it. I don't know why, but these are all the solutions if we're looking for real solutions. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.